So here our logarithmic equations are going to get a little more complicated. What we can do is solve them using properties that we talked about with logarithms. So when we went through properties, there were a lot of them, and they're all right here. The ones we're going to focus on using really are 5 and 6, though we've seen in solving exponential equations. Even in that last video, this exponent rule comes up quite a bit too. So really those three are what we'll focus on. Then on here is also your change of base formula, and then just some properties for how values cancel out when the base of the logarithm matches the base of the exponent and things like that. All right, so what we have here is two logarithms. Now, in the last video, we saw a case with two logarithms. The idea was that we didn't have anything adding or subtracting on outside. So if I moved this logarithm to the right-hand side, I would have this +1 outside of it. So I can't use that property that we used in the last video. Instead, what we can do is use the fact that we have a logarithm of the same base adding on to itself. So we have addition outside of the logarithm. So what we can do is condense this into a single logarithm. So a logarithm base 6. And inside the logarithm is going to be the multiplication of the two pieces. So we'll have x plus 4 times x plus 3 equals 1. And now I'm at this stage where I have a single logarithm with a base and a value equals a single number, which is our exponent. So what we can do is change to exponential form. So what we're going to do is we'll have the value alone on one side of the equation. I'm going to go ahead and multiply that out. So x plus 4 times x plus 3. So with a little foiling, that'll give us an x squared plus 7x plus 12 equals base of 6 with an exponent of 1, which is just 6. And now what we have here is a quadratic to solve. So we go through our methods of solving quadratic equations. So I'm going to subtract 6 from both sides, so I have 0 on one side of the equation. Then we can use our skills of solving quadratic equations. So with this, I'm going to go with factoring. I usually look for factoring first, and then if I can't factor, I go to the quadratic formula. You can always use the quadratic formula. It always works, so it just depends on your comfort level there. So you can either factor or quadratic formula. So I'm going to go ahead, and this will factor nicely with an x plus 6 times an x plus 1, which means we can separate to x plus 6 equals 0 or x plus 1 equals 0. So we're going to see x equals -6 or x equals -1. But then we have to check our solution. We need to make sure these work. So logarithm base 6 of -6 plus 1 plus logarithm base 6 of -6 plus 3. And is that going to equal 1? Well, what I can notice here is adding. So this would give us -5 inside there. This will give us -3. And we can't do that. We can't take the logarithm of a negative number. So that's going to not work. So we'll check for -1. So logarithm base 6 of -1. Oh, sorry, I said 1, that should be a 4, but still holds true. But just instead of 1 there, be 4, so that would be a -2 inside. All right, -1 plus 4 plus logarithm base 6 of -1 plus 3. So is that going to equal 1? So this would be logarithm base 6 of +3 plus logarithm base 6 of +2. And then what I'm going to do is just go to the calculator there. I'll need to use my change of base formula, but logarithm of 3 with logarithm base 6 plus and then it was logarithm of 2 over logarithm base 6. And there's our value of 1. So that one checks out. So x equals -1 is a solution. So sometimes with these, you might start getting this instinct like, oh, x is negative, that can't be a solution. But it isn't true. It's after you plug in the value, because there might be some math to do around that negative number that ends up making the value inside the logarithm positive. So just be careful, but it is a good instinct to have that as negative numbers come out or zeros come out, a little red flag warning should be going up that it might not work. All right. Our next case here. So with this one, we have subtraction between our two logarithms. So what we'll end up doing is division of these pieces. So we can combine this to a single natural logarithm with x plus 1 over x, and that equals 2. So now I have logarithm equals a number, so we can change to our exponential form. So on one side of the equation, we'll have the value inside the logarithm. We have base e and an exponent of 2. And I'm going to leave e squared just like that because I don't want to round anything yet. Let's see, to get rid of the denominator of x, I need to multiply both sides by x. So I'll give me x plus 1 equals e squared times x. And then we would do our move of moving everything with x to one side of the equation. So I'm going to go ahead and subtract x from both sides. So that on the left-hand side, we'll just have 1 equals e squared times x minus x. Then I would go and factor out a value of x. This is kind of like with our exponential equation. So I factor out x, and that would leave me with an e squared minus 1. And now that I've factored out x, I can just divide all of that away there. So divide by e squared minus 1, divide by e squared minus 1. So x is going to equal 1 over e squared minus 1. And with that, we would want to check that out. I'm just going to go direct to the calculator with this one. So natural log of 1 over e squared minus 1. And then we have a plus 1 inside that first logarithm. And then we're subtracting the natural log of x, which is the 1 over e squared minus 1. So we get our answer of 2, so that all balances out. So it checks, and we have our solution. All right, let's do 2 more of these. So here we have addition between the two logarithms. So we can combine them to a single logarithm with multiplication of the inside, so the x plus 1 times x plus 7. Equals 3. And then we can change to exponential form. I'm going to go ahead and FOIL out the x plus 1 times x plus 7, which would give us x squared plus 8x plus 7 equals base of 2 to the third power. So this is x squared plus 8x plus 7 equals 8. And then to get 0 on one side, I'm going to subtract 8 from both sides. So this gives me x squared plus 8x minus 1 equals 0. So if I try to factor this, I'm going to get stuck because there aren't two values that multiply to 1 or multiply to -1 that add up to 8. So we're going to need to use our quadratic formula. So I'm going to go x equals, and let's see, we have a is 1, b is 8, c is -1. So negative b plus or minus the square root b squared minus 4ac all over 2 times a. And then just simplifying this down, so -8 plus or minus And then I like to simplify that square root. So that should simplify down to 2 times square root of 17. How I got there, I'll go through that. It's always good to have practice with these. So that square root is going to be the square root of 68. And then simplifying our radical, I just start thinking about factors. So I could divide out a 2, which would leave me with 34. I could divide out another 2, which would leave me with 17, and then 17's prime. So with that, it's this 4, square root of 4 will give us the 2, and then that 17 stuck underneath, and then 2. So for an exact solution, we would have a negative 4 plus or minus the square root of 17, with that 2 kind of canceling out with those pieces. And from there, we can get decimal solutions. So looking at the addition of the two numbers and the subtraction. So we should have a 0.1231, or x equals negative 8.1231. And so I'm just moving a little fast here for the length of the video, but with that, we would check both of these. In this negative 8.1231, we're going to have issues when we plug that in both cases. It's going to make a negative number in those logarithms, which we cannot have. So that won't check, but if you plug in the 0.1231, that'll work great. So for the exact solution, we would have the case of the addition of the two numbers would be exact, and then we have the decimal form. All right, one more example here. So with this case, our logarithms are on different sides of the equation. However, we have this 1 on the outside of it, and we can't have that. So what I want to do is move the logarithms so that they're next to each other. So I'm going to do is add this logarithm base 5 of x minus 1 to both sides of the equation. So that we get to our form logarithm base 5 of x plus 3 plus logarithm base 5 of x minus 1 equals positive 1. And now I have addition of two logarithms with the same base, so I can combine them with multiplication of x plus 3 times x minus 1. And that's going to equal 1. Then I can make my change to exponential form. So I'm going to FOIL out the inside there, so that'd be an x squared. See, positive 3 minus 1 would be a positive 2. 3 times negative 1 is negative 3, equals base of 5 with an exponent of 1. Now to get 0 on one side, I'm going to subtract 5 from both sides of the equation. And then this is nice and factorable. So I'm going to factor for an x plus 4, x minus 2. Again, those two numbers multiply to negative 8. Positive 4 minus 2 would give us positive 2. Okay. So with that, we get x plus 4 equals 0, x minus 2 equals 0. So x is going to be a negative 4 or a positive 2. We have to check our solutions. If I plug in negative 4, so negative 4 plus 3 will be a negative 1, so that's not going to work. Also doesn't work over here. It just has to fail for one of them to fail for the whole thing. So negative 4 does not work. We plug in positive 2. 2 plus 3 is 5. That works great. 2 minus 1 is 1. That works great. So we're going to find x equals 2 is our solution.